At DTS, we love to help customers find solutions to measurement challenges. One of the most common application questions we get is with regard to choosing appropriate accelerometers for a testing project. Hi, I'm Mike Beckage, co-founder of DTS, and this video is intended to guide you down the right path when choosing accelerometers. There are many sensing technologies, but there are a few basic questions about the application that we need to consider first. There are 6 key parameters you need to consider when choosing accelerometers. The first of these is, does your application require DC or steady state response? Some accelerometers only respond to changes in acceleration above a certain minimum frequency and thus do not have DC or steady state response. IEPE sensors fall into this category and are generally not the best choice for quantifying long duration or asymmetric acceleration pulses. IEPE sensors are great for quantifying vibration and for short-term shock events, but if your application requires integrating the data to calculate velocity or position changes, you simply can't do it. If you do require DC or steady state response in your accelerometer, there are many choices and many different technologies. For example, piezoresistive, MEMS, and variable capacitance all have options that give you that DC response and the ability to integrate the data. The second key parameter to consider when choosing accelerometers is what measurement range do you need? Now, in some applications, it's very clear because the measurement range is specified in a test procedure. In some other experimental work, though, it might require some engineering judgment to make a decision about the range. Just remember that it's always best to choose an accelerometer that has a full-scale range at least double what the highest expected measurement is. This is because once data are clipped and you've exceeded the range of the device, you've lost any data beyond that point. The next key parameter is what bandwidth do you need? Bandwidth is the range of frequencies over which accurate and linear data are required. For a DC response accelerometer, this would be specified as a range, for example, from 0 to 2000 Hertz. For a non-DC response accelerometer, it might be 5 to 1000 Hertz. So how do you know what bandwidth you need? Well, generally, this would be specified in the test procedure you're working from, or perhaps from the engineer who designed the test. The fourth key consideration is damping. Some accelerometers have internal damping mechanisms, and others do not. The key thing to remember is that all acceleration sensing elements will have a natural frequency. Undamped resonance or ringing in accelerometer signals can cause serious measurement errors if not properly considered. Just remember that some damping is desirable in the accelerometers you choose for most applications. This is actually quite a big topic and covered in greater detail on the DTS Help Center. The fifth key parameter has to do with basic electrical considerations. The first of these is, of course, the excitation voltage. Is it compatible with the power requirements of the sensor? Typical DTS data acquisition systems have 5 or 10 volt excitation, and so the sensors you choose need to work on those voltages. And secondly, are the sensor input voltages of the DAS compatible with the sensor output? Typical sensor input ranges on DTS DAS systems are 0 to 5 volts, or plus and minus 2.5 volts. Last but not least are any environmental considerations that might drive your decision when choosing an accelerometer. And the top 2 concerns really have to do with how well the sensor makes accurate measurements over the temperature range it's rated for, and this includes things like the stability of the sensitivity and the 0 level, and then very basic properties of intrusion protection. Is the sensor protected against dirt and dust and moisture? DTS specializes in miniature, rugged DAS and sensor solutions, and so we are well prepared to help you with your application questions in this area. Accelerometer designs vary greatly, but the basic principles apply to many sensor types. Hopefully this information will help you make decisions when choosing sensors, or at least help you formulate questions when you contact DTS for applications assistance. We have lots of additional information available on our website and Help Center, so take a look and let us know when you need help. Happy testing!